You probably know Finland is the happiest country in the world. But did you know Finland has the highest incidence rate of type 1 diabetes? In fact, 1 in every 100 Finn is affected by this disease. It's not just here. Globally, type 1 diabetes is rising, with over 9 million people are living with this disease. This devastating disease often strikes early in the childhood. It uses our own immune system and destroys these insulin producing cells of pancreas. Insulin normally allows our body to use sugar as energy, and without insulin, it's life or death. And that's heartbreaking. The only treatment from past 100 years is lifelong insulin injections. We still haven't found a cure, and there is nothing you can do to prevent this disease. But I think the solution lies in the immunity. At the moment, many studies are targeting these immune cells to slow down the disease development. But to prevent this disease, I think there are two big challenges. First, we don't know which immune cells are precisely going wrong. Second, how do we even track them before the disease develops? That's the challenge I'm addressing in my PhD. The two important highlights of my research design include first, using precious blood sample collected from small children just after the birth and then at regular time interval until the children develop type 1 diabetes. Now that's way early than any published research study out there. The second, utilizing cutting edge single cell technology, which allows me to precisely identify every single cell and look deeper into its genetic content. Now, in my research, I focus on the subset of immune cells which are known to help in the destruction of pancreas. I performed a single cell experiment and found out that there are 10 different types of these cells. But there is no difference in the number of these cells between the children who get the disease and those who don't. So what's the issue? It's inside these cells, the changes in the genes themselves. And that's what is affecting the function of these cells and contribute to the disease development. Actually, I have already identified 8 genes which are clearly different and not reported to play a role in previous type 1 diabetes studies. So what's the impact of my research? Now, in future, we can use these genes as an early biomarker. We can track the disease early. We can identify children for precise immune therapies. This gives them a chance to prevent the disease. Most importantly, my research will truly make Finland the happiest country in the world without type 1 diabetes.